So we'll try to solve some numerical, some sequences and series. Okay. So what is a sequence? Okay. So sequence is an arrangement of numbers in definite order according to some rule. Okay. So it's arrangement of numbers. Arrangement of numbers in definite order as per some rule. So this is sequence. Then what is series? So series if the terms of sequencer are connected by plus or minus sign. Okay. So if the terms of sequence are connected by plus or minus sign, this becomes a series. Okay. Okay. So there are two common sequences we have come across. One is called arithmetic progression, AP. Okay. So that is arithmetic progression. So in arithmetic progression, the terms increase or decrease by a fixed number. Okay. So let us say you have A1, A2, A3, A4, A5, like that you have AN, nth term. Okay. So here A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to AN minus 1 is equal to one constant on D. So this is arithmetic progression. Similarly, there is something called your geometric progression. Okay, so you can take a picture of this. So there is something called geometric progression. So in geometric progression, the successive term is obtained by multiplying the previous term by a non-zero constant. Okay, by a non-zero constant. Okay. So you have AR square, AR cube. Like this you have AR to the power n minus 1. That is the nth term. Okay. So there are some formulas related to AP and GP. Okay, so let us write the formulas related to AP. Okay. So So any term, okay, so any term, okay, any term, and then you have sum of n term, okay, sum of n term, okay, that is, this is in AP, okay, this is in AP, okay, so any term you can write say an, any term means nth term, n can be anything, 1, 2, 3, 4, so any term an is equal to, so it will start from first term is a0 plus n minus 1 into d, okay, so this is any term you can find out. Then sum of n terms, okay, Sn is equal to n by 2
into 2a plus n minus 1.
2a plus n minus 1 into d, okay, or it can be written as n by 2
into a
first
plus
term
a,
and last term.
a plus an.
A last term, let us say first term A, last term L, okay. So first term, so the last term is this 2A, na? Out of this 2A you write A and the last term. So, so this is the formula for AP, okay. So this is the formula for AP, okay. Similarly you have GP, okay. So you have GP, that is your geometric progression. Okay, so what are the formulas valid for GP? Okay. So here you write your any term, okay, and then sum of n term. Okay. So you can write it as an in GP and Sn is sum. Okay. So the formula for an in GP is a r to the power n minus 1. A r to the power n minus 1. This you have to remember. Okay. Then the sum Sn is equal to this you have to remember
R
a into r to the power n minus 1 divided by r minus 1. This is if r is greater than 1.
Then if r is fraction, then it will be 1 minus r.
And there is something, if you have infinite number of terms. Okay, so for infinite number of terms, the formula for Sn will become a by 1 minus r. This, some questions can be like this, for infinite number of terms. Okay, because it will become r to the power infinite, and if r is less than 1, so this will get simplified into this, a by 1 minus r. Okay. So that is for infinite number of terms, that also you have to remember. So these are some of the key formulas. Using, if you have the understanding of this, you can solve many more complex problems. Okay, so take a picture of it. And there is something called arithmetic mean and geometric mean. So arithmetic mean, if first term is A and last term is B, arithmetic, so if there are two numbers A and B, arithmetic mean is A plus B by 2, geometric mean is square root A by AB. Okay. So if any two numbers. So A and B has to be in, A and B are in arithmetic progression. Then only mean is A plus B by 2.
Yeah.
Okay. So, and if, So arithmetic mean between two numbers a and b is given me, such that a and b are in AP. Okay. Okay. So geometric mean is square root a by b. So here this becomes like a plus b by 2, and b. These three numbers are in arithmetic progression. Okay. Similarly here a square root a b and b. These are in geometric progression. Okay. Okay. So there are some special series which normally I have seen some G numericals are coming based on that. So those special series are like this. So sum of squares of first n natural numbers. Okay. So suppose you want to find the sum of squares of first n natural numbers. 1 square plus 2 square plus 3 square plus 4 square.
N into n plus 1.
And then n square is equal to n into n plus 1
by
into 2n plus 1 divided by 6. Okay, so this is sum of squares of first n natural numbers. Similarly, sum of cubes of first n natural numbers. Sum of cubes, okay, then n cube, that is equal to n. So that is equal to n into n plus 1 whole square divided by 6. Okay. So now this whole thing divided by 6. Sorry, I think, yeah, whole thing divided by 6. Okay. This you have to remember. There can be questions like this. Okay. And there is something called harmonic progression. So if you have 1 by a, then 1 by a plus d, like just the reverse.
Yeah, I understand.
1 by a plus 2d, these are called harmonic progression. Yeah. Okay. Okay, so basically these are the one. So we will try to solve few numericals based on this. You take a picture. Okay, so we will try to solve few numericals. Okay, so this is one arithmetic progression. Okay, so the question is like this. The 25th term of an AP is 15. Okay.
A plus 2040.
Yeah. So 25th term of an AP is equal to 15. Okay. 15th term is 25. 15th term of an AP is 25. Okay. Then what will be the 40th term? 40th term, how much? Okay. So you know that formula a plus n minus 1 into d.
A plus 24d and a plus 14d.
So is 15. So a plus 24d is equal to 15. A plus 14d is equal to 25. That means 10d
is equal to
minus 10, right?
Yeah.
That implies d is equal to
minus 1.
Minus 1. So nth term, so an is equal to a0 plus n minus
40th term is directly a plus 39d.
So
you have to find a.
How much is a?
You have to substitute d in that equation.
So a plus 14 into minus 1 is equal to 25, right?
Yeah.
So A minus 14 is equal to 25.
Yeah.
So A is equal to 39.
Yeah.
So this is 39 plus
39D
39D. Okay. 39 minus 39 is equal to
0.
0. So okay, so 0 is the answer. So this is very simple one. So okay. So we'll try to um, do one more on geometric progression. Okay. So the third term of a GP is 9. The product of first 5 term is, okay. So we do something like this. Let us say the third term
A3
is 9. Okay.
AR square.
The third term is 9. The product of first 5 term. Product of first 5 term is how much? So here you can write it like this. So let us say first term is A by R square. Second term is A by R. Third term is A. Fourth term is AR. Fifth term is AR square. Okay, so your yeah. So your third term A is equal to 9. Okay. So so now you want to find out the product of first 5 terms. Okay. So product of first 5 term will be A by R square into A by R into A into AR into AR square. Okay. So R square cancel, RR cancel, it will be 8 to the power 5. Okay, so this will be 9 to the power 5. That will be the answer. That is 9 to the power.
No, third term is A, so AR square is 9.
Okay.
A is not 9.
Okay. So AR square is 9.
Yeah.
Okay. No, third term is A, na?
Third term is A.
We
Okay,
have.
we took. Okay. Yeah.
So A is equal to 5. Okay.
9 to the power 5. Yeah.
So So 9 to the power 5. So the answer is 9 to the power 5, which is otherwise 3 to the power 2 to the power 5, which is you can write as 3 to the power 10. Actually, this is given as the option.
Same.
Okay. So that is the same thing. Okay. So take a picture. There are. We'll do one more numerical and geometric progression. That is. The sixth term of a sequence is a sequence 3, 1, 1 by 3 each. Okay. So you have 3. You have a sequence called 3, then 1, then 1 by 3. Okay. So this is your sequence. Okay. So they are asking what is the sixth term. Okay, so the formula is AR to the power n minus 1.
AR to the power 5.
So A is equal to 3, R is equal to 1 by 3. Right?
Yeah.
So A, R, 6 minus 1 is equal to AR to the power 5. So 3 into 1 by 3 to the power 5.
1 by
3 by
1 by 3 to the power 4.
3 by 5. So 1 by 3 to the power
4.
So this is the answer.
1 by 89. 81.
No, I think 1 by 81.
Yeah.
Okay.
R is
1 by 81. Okay. So there is one question on infinite series. So we'll do this is a tricky one. We should remember it. Okay. So you have to. So one infinite series question is there. Okay. So what is the sum of the geometric series 6 plus 3? So 6 plus 3 plus 3 by 2 plus 3 by 4. Like this it goes until infinite. Okay. So we know formula for infinite is a by 1 minus r, right?
Yeah.
That's the formula.
Yeah.
So your a is 6, okay, and r is 2, right? 2, right?
Yeah.
So your total Sn for infinite series is equal to 6 divided by 1 minus 2, right? So
Yeah. No, R is 1 by 2.
r is 6 by 3. Oh, half. Sorry.
Half R.
Half. 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 Okay, so 6 by half is equal to 12. Okay, so the answer is 12. Okay, so just remember it is a by 1 minus 1.
1 minus R.
A by 1 minus r. That is infinite series.
Series in G.
Yeah, 12 is the answer. Okay, so like this there are very large number of questions which you can practice in arithmetic, geometric, and harmonic series, and this infinite series, and that formula is 1 square plus 2 square plus 3 square, that one, and 1 cube plus 2 cube. So if you remember these formulas, knowing these basics, you will be able to solve any numerical. Okay, okay, thank you.